list of things. I can't remember them off the top of my head. One was type 1 error, type 2 error, and a few other things. So you tell me where you want to get started. I'll try and go over each one.
Sure. I just have 3 separate little note pages for my notes for the final. I have formulas, tables and graphs, and vocabulary.
Okay.
So I'm thinking let's start with vocabulary because I think there's the most in vocabulary.
Okay. So what's the question that you've got? What were you not sure about?
I was looking at like independent events, mutually exclusive, stuff like that. And then they were talking about complementary events. And
Yes.
I was looking around and I completely forgot how to tell if an event's complementary. So I'd like to write that down so I know how to tell if an event's complementary.
Here we go then. I'll put it on my white screen.
Perfect.
Complementary events, and let's call them A and B, have the property that the probability of A plus the probability of B equals 1. And that can happen for all sorts of reasons.
So that would mean that it is complementary if that was the case?
Yeah, if that was the case. And the second part of this is let's phrase it the way. B is the event, not A. So B is the exact opposite of whatever A is. So if A is boys, B will be girls. If
Wouldn't that be the complement?
Yes, but that's complementary events are the complement. I mean, it's the same term, really.
Okay. So if there's an event and then the other event is the first event's complement, are they complementary?
Yes.
Okay.
That was easier than I thought it was going to be.
Yeah. It's mostly just reviewing things because, like, I've already known this. I've already been taught it. I just need a reminder on some of the things. I couldn't find some notes about a couple of things. That's just we did it a little bit ago.
I mean, and the fact that complementary events, when you add the probabilities, it's always 1. It's sometimes quite good.
That's pretty easy. I knew it was something like that. I just didn't have the PA plus PB equals 1, and that's just what I needed.
Okay, what's next?
Type 1 versus type 2?
Yeah, okay. And type 2. These errors occur in hypothesis tests.
Okay.
So let's right, so you've got a null hypothesis and you've got an alternate hypothesis. Let's put numbers in it. Let's suppose that the null hypothesis is that P is 0.5 and that the alternate hypothesis is that it's bigger than, just for an example, right? But you could do it with anything. You could do it with the mean is 42 and the alternate is the mean is not equal to 42. Right. So the 2 types of error that you get, the first one is you reject the null hypothesis when it is true. And that's called the type 1 error. That's actually what alpha is. Well, at least that's the range of it. Its exact value is its p-value. So you reject the null hypothesis when it's in fact true. So you do, you collect a sample and just by bad luck, you actually prove that this is true, because you got to remember when you say one thing, it can also mean the exact another thing. So if I say to you, I'm rejecting the null, is it not the same as I'm accepting the alternate, right?
Yeah.
So that's why there's so many different ways of phrasing the same thing. So the first kind of mistake is error. that you reject this one, right? When it in fact is true. That's called the type 1 error. And the second one is you don't reject H naught when it is false. And we call that type 2. So can you imagine a situation where you thought that this was true? You did a sample, you did an experiment, you got your information, and at the end of the day, you didn't reject H naught. But in fact, you should have, right? This was true. You just didn't manage to prove it.
Yeah, I remember the questions involving like COVID, the testing.
Yes, and that works for false positive and false negative.
Like
One of these is a false positive and the other's a false negative.
And the false negative is a lot more scary.
Right, and sometimes you can't make both of them small at the same time. If you decide you want to minimize this by making your alpha, 1% or 0.1%, then this is going to get bigger. And if you make this nice and small, then that's going to get bigger. It's like a seesaw. As one goes down, the other has to go up, right? There's no way you can make both go down at the same time, except by having bigger and bigger and bigger samples. Because when you have bigger samples, all errors reduce. But if you're fixed with only 100 people, there's, if you want to make one of these errors smaller, you're going to make the other one bigger. Another equivalent to a type 1 and type 2 error is, one of them is you put a guilty person in jail, and the other one is you let an innocent person, let's say you put a guilty, I'll get this right in a minute. You put an innocent person in jail, or you end up letting a guilty person go free. These would be the two types of type 1 and type 2 error. Yeah. So if you said the null was he did the crime and the alternate was he didn't do the crime, you could imagine court cases where the evidence was very strong, and so he ends up in jail, even though the guy didn't do the crime, because that does happen. Okay, so that's what a type 1 and a type 2 error is all about. Okay. What's next?
Is one-sided versus two-sided tests. I kind of remember it, but I don't really remember how to tell the difference, and I just want to.
Okay, let's show you. That's also connected to hypothesis test.
Yes, hypothesis test. I had some troubles on. I think that's also when I was 6, so I was kind of half in, half out.
I hear you. Right, so a one-sided test would be. This is an example of it. Let's keep to my P, guys. You said it was 0.5, and the alternate is you believe it was bigger than 0.5. That is called a right tail test. And it's also at the same time a one-sided test, because you're only looking at the right-hand side, essentially. Now, you could have had a different hypothesis where you actually thought that the p-value was less than 0.5. And that is called a left tail test. And that is another example, just a different looking one, of a one-sided test. So if you ever see the alternate is p or mu bigger than this number or less than a number, these together are one-sided tests.
Okay, so if it was like exclamation point equal sign, or like not equal.
Right, so that'd be not equal. That's a two-sided test.
Okay.
So if you had this one and you thought that it was different than 0.5, then you would call that one a two-tailed test. But there's only one version of that, so you don't need to have two versions as we did here. There's not a left and a right version of a two-tailed, it's just two-tailed.
Yeah. But
there's a left and a right version of a one-sided test.
Okay, that makes sense. Nice. What other? Okay, I think that's it for vocabulary. And I don't think I had anything in tables and graphs. I think I might just have like a formula or two. Oh yeah. I was looking through the homework questions, and in like one of the very earliest chapters, it had you finding the standard deviation from just like a list of numbers. And I was wondering how to do that, because I'm sure I knew how to do it at the beginning, but I have no idea how to do it now.
You need to use your TI-84 calculator. So let's suppose I collected some data and the numbers were 5, 3, 8, 7, and 1, right? Keep the numbers simple. And you want to get the standard deviation. I mean, you could do the mean by just adding them up and dividing by 5. People don't have problems with mean, but standard deviation is much more complicated. So first thing you'll do is you'll hit the Start button. And then you're going to choose option 1, which is Edit. And as you can see here, some old data left behind. I'll just hit Delete to get rid of it. And then you type in the data. So in this case, you would type in 5, 3, 8, 7, and 1. Okay, and that's the information now in the calculator. It's stored there. Then when you do next is you hit the Start button a second time. And you move your cursor over to Calc. And you choose option 1, which is called One Variable Stats. And it depends on if you've got an old or a new version of this calculator, what's about to happen next. I've got the old version. So when I hit that, all you see is a little flashing black cursor. And I have to tell it where to find the data. And I put the data in, when I did it up here, into L1. So to get L1, we hit the blue button and a 1. And you see the L1 appeared.
Yeah.
So it's going to go and find, you know, the thing I want, in this case, the standard deviation, and it's going to get the data from L1. That's where it was typed in here. If you looked at the top, there'd be a thing saying L1 and all the numbers underneath. So when I hit enter, you got a whole load of guys. Now, the guy that you typically want is SX, because he represents the standard deviation of a sample. And we will assume, unless you're told otherwise, that this is just a sample of numbers from a population. So in this case, the standard deviation was 2.86, at least to 2 decimal places. Now, the guy that's underneath it, which you typically will never use unless it's a very special case, the one that looks like that, is also a standard deviation, but not one that you would typically use. And it's a standard deviation of the entire population. So if you knew that there were only 5 rare ducks in the world, and this is what they all weighed, right? Well, all 5 of them, that was it. Then you could use this to calculate the standard deviation, because the entire population only consists of 5 things. But that's pretty unlikely, right? So you don't expect to use that much. Okay. This is the guy you would typically use in any normal question that you'd ever see.
Awesome. Thank you. Yeah, no, just because I wasn't sure if that was something to do on Salt or a calculator or something to do by hand. So
if you got a question where there was a Salt button, you could do it on Salt.
Okay.
You would just go to the can't remember what the title is at the top, but there are places up the top.
Put data or something, or data.
Yeah, and when you hit that menu, it'll say, where's the data? And you would say, it's frogs' weights, or whatever the story was about. Very often they have a little name for it, so you know what data to choose. And then you hit the button and it tells you, well, no, I mean, this one tells you all sorts of things that you don't really need to know, but you might. There's the mean, 4.8. if you added all the numbers up, it would be 24. And if I scroll down, you actually get the 5-figure summary as well.
Oh, wow.
So if you wanted to do a box plot or something, it might be.
Yeah, no, there you go. That works.
Okay.
For the next one, how to calculate approximate proportion.
I'm not sure what that meant because I don't recollect the word approximate. I know what proportion is. That's just
Yeah, that's why I
guesses
was
out of
confused.
totals. So
I
who
was-
asked you? What question phrased it that way, I guess?
I'm not sure. I'm thinking somewhere in chapter 2 because my chapter 3 notes start directly after that. So chapter 2, it was just they were talking a lot about like approximate proportion, and I think it was something that they were trying to have me calculate. So let me look and see if I can find like a question that asks. Just because that was confusing.
I suspect they just put in the word approximate because in the story it was an estimate based on something. You know, they asked 200 people and approximately 82 of them said yes. I mean, I guess that's not a very good answer, but I mean, approximate just means it's not perfect. It's
Close.
It's close. Proportions tend to be values you're told. You know, you asked 400 people and 33 said they like Pepsi. I mean, there's no argument about what the numbers are. I mean, I can't think of off the top of my head a situation where you wouldn't know exactly the top number or the bottom number. I can't think of one. So I think it may be a red herring, and the word approximate probably shouldn't have been used. It should have just said proportion.
What chapter did we learn about the value of variance in?
Variance? That
Yep.
was way back at the beginning, so that would be very likely to be checked. Let me check the numbers by checking the syllabus. It's the easiest way for me to do it.
Because I wrote down about approximate proportion at the same time I wrote down the value variance formula. So
okay, in here, and let's see what it would be. Numerical summaries, chapter 2.
okay. I don't think it was mentioned in this one, but probably the one right after. Yeah, let me look. Sorry.
Well, yeah, it's fine. When they do the bell-shaped data, sometimes they do the 95, 90, let's say again, 68, 95, 99.7 rule. They might have used the word approximate there.
Yeah, they could have.
Because approximately 68% of the data is within one standard deviation of the mean. So that's pretty common to use the word approximate there.
Asking for standardized score, standard deviation. Yeah, they said this is the first time I've seen the word approximately, but they're just talking about the bell shape.
Maybe that's all they were doing, and you read more into the word approximate than you needed to.
Possibly. I'm just going to check on the chapter and make sure I'm not missing it. Otherwise, I'll leave it alone.
Chapter 3 is regression lines and scatter plots. There won't be any proportions in there.
Oh, okay. Well, then I'll just leave it alone. I don't know why I don't know. I think I was looking for questions and I saw it and I was like, oh, that's weird. I wonder. Yeah. So approximate.
Yes, I do. I have not in any of the lessons that I've given use that phrase in the way that it looks like you thought it was being said. I mean, I have used the word approximate, but you know, that's in everyday language. Like you would say, approximately 6 to 8% of the data is within one standard deviation. And that is a proportion, 6 to 8%. And so you're saying approximately 6 to 8%. I guess I could use it in that context, but that's the only one I can think of.